are some of the things you dealt with, and how did you address them?
Yeah, that's a very good question. So we use AWS very heavily, and like for us, dev and prod is different accounts, which has its own restrictions because it has its own resources and network pairing and stuff like that. So in order for us to like ensure we can have same environment, so we allow only do development in the dev account. We don't allow users to do any development in production. So all the configuration which we use to the remote machine, we mount the same configuration when they run things locally, which ensures that they have same access to the AWS credential, they have same environment configuration they need to run things locally, and all the dev resources are accessible from their local environment as well. So they can run, they can integrate, and they can test things. In order to go from dev to prod, there are different strategies we chose. Like, but the most important one for like feature store related pipelines, the way we do that is when people run a dev pipeline and it's successful and it registers all the features to dev, we in our platform transition that pipeline to production rather than users deploying a new pipeline to production.
Right.
So like our dev pipeline success is for us a signal saying this pipeline works with all the tool sets we have and it's computing the features reliably. We can transition now that pipeline from dev to production. So that's something which we use in order to transitions accounts or states for features. For other things, the workflow is a little bit different. For example, for model training and storing, we don't want people to deploy dev models to production. Like we have our own process so that they release a code to masters to make sure things are reproducible, and then they follow that process to productionize any service or a model. But for
So you
features,
manage like any model that goes to production. It's actually your system that manages the training of that model and then the promotion to production.
yes.
So your customer, user, whatever, would not ever build a model in some way that you guys don't need to know about, and then just give you a model and then you serve it.
Uh, so, so one thing we try to do is we try to standardize the interfaces between different products. So for them to use like model serving platform we have, they have to package their model with our SDK so that we can reliably deploy that model to serve. And then in order to test that deployment, we have like stepwise deployment where we deploy to dev first, run some sort of integration test to make sure it meets all the SLAs. Then we deploy to production with like a canary deployment so that we can roll back anytime there's an issue. So that's how we try to make it reliable. But we do support users creating their custom models and applications. The only thing is they have to use that boundary interfaces which we have created in order to integrate with our
And they're
platform.
kind of a little bit more on their own, and there's less promises that come with that and stuff like that.
Yeah,
And
exactly.
then going back to the kind of feature management point, so you said, hey, we have a way for people to author feature pipelines in the dev world, and then I think you said we don't, or maybe I got this wrong, but I think you said we don't ask them to rebuild a new feature pipeline. We just, did you say you upgrade it or promote it to production for them so they don't have to rebuild it in production?
Yes, so all the feature pipeline in dev, they computes feature based on some query or something, and then store data in a dev environment. Then once the pipeline is working fine, we just export that data to production saying this feature is productionized, now it's immutable, you can't change it.
You
So people
export the
can,
computed data to production?
no, like the pipeline,
Of the
we
pipeline,
export the
okay.
pipeline so that we compute every day in production. But the moment we do that transition, we make the whole pipeline immutable so that people can't change any of the logic.
Cool. And one challenge that I've seen other teams deal with in that same, when they try to do what you're doing, and often it's unsuccessful, is the data sources that are available to a production or to the dev environment and the production environment are different. And so it's hard for them to do a to like actually take that same data pipeline
Yeah.
and just promote it. What are the details of that for you? Is that not a challenge for you guys?
We have a centralized warehouse. Like we currently use Snowflake, so it's accessible. All the data sources are accessible to both the environments. And then we have our real-time pipeline running on Kafka, which is also accessible to both environments. So
Okay.
for us, because we have a centralized storage for this data, so it's not a big challenge, but we can, like, all the isolation happens on the compute level, not at the storage level.
Got it. Cool. And so maybe we can talk through some of the stages that you went through to adopt more and more real-time ML. And maybe we can just start with like understanding why you even did that. Like, why was real-time important and how did you know it was important?
Yeah, so I was saying like batch inference was good for us to test things very quickly, right? Then we moved to, there was this bridge which we mentioned, like going to online service. So that was useful for us to create this feature for infrastructure. Plus, it was useful for us to handle those tail queries which we couldn't compute during batch. So that was an upgrade from batch. And then we introduced a production critical system. So the next upgrade was, now we are using all the batch features in our feature store, which are computing every day or every week. Now let's introduce more real-time features, which are computed every minute or every few minutes.
And before doing that though, how did you know that would like, because going to real-time features, that's a big effort. And so
Yes.
was it obvious that would be worth it? Or were you like, hey, let's try this, but it's a big guess?
Yeah, that's a good, like, I think the reason we tried for the first application where we wanted to do personalized recommendation, and we could only do personalized recommendation if we start reading a lot of user session information. So that was the first use case. So we tried with that use case where we build some user specific features so that we can recommend products which are more preferable to that particular user based on their history during that session. That was the first use case. Like we wanted to test the use case, and we had a hypothesis that this will provide a benefit. So that's how it started. So once we had a success with one use case, then we built like the whole group around real-time features where it had a representation from machine learning engineers, the infrastructure engineers from both data platform and machine learning platform. And then that group will decided like which is the next set of features they want to launch and what are the applications which can benefit from them. So that's how it started. Like now we are in a stage where we want to make it like self-serviceable so that people can just go and deploy their real-time pipelines and compute features without worrying about a lot of infrastructure related stuff.
And do you guys have this concept for real time? When we say real time features, you know, in the Tecton Feast world, we talk about batch computed features, streaming, aggregation features, and then actual real time features. We call them on demand features, which use, you know, something that comes from, say, like a search query or something that's only available at prediction time. Do you have all three of those, or do you classify things in a different way?
So that's a good question. So in the second stage, we could actually use the batch plus the real time in Tecton world, where we could send context in a request, which is all available at the backend at that time. So that's the introduction in the second stage, where we could now use the context of the request to do like better prediction. And then the third stage was like the streaming aggregate features, which require us to like aggregate a set of time and like events in some time frame so that we can compute some information from it. So so that there were three stages. So the second stage was useful because first we could handle tail queries, and then we can also introduce context based in the backend.